All right, class, let's go with it here. We're continuing our lecture in H6. We are solving inequalities. It's been a fun experience, and we got to fractions here. So let's see as we do this here.
Could you make the problem big again?
Oh, yes. Thank you so much. Go for it. All right, so we were dealing with fractions here. The last problem that we did, we just multiplied straight on through with the common denominator, right? Well, that one, once you multiply straight on through with common denominator, fractions are gone, and yes, you don't have to deal with fractions ever again. Number 34, slightly different. Number 34 has a fraction, but it's right in front of a parenthesis for distributing first. So whenever you have a distribution on your hands, usually we distribute first. And then we're going to do, and math is kind of funny because it builds on itself. So once you finish like one step of 34, it's going to look like 32 now. And then you just finish off the same process. We're good? So are we good writing it down? There you go. I go like this. Cool. Let's jam with it here. So first things first, I'm going to multiply this into here. Oh, that's why I did it. That's why I went this way. I'm going to multiply this into here, and then that into there. Off to the side here, 3/4 times 16, and we would say 16 over 1. Everybody good there with 16 over 1? We're multiplying 3/4 times 16. And how about this? That goes to a 1, that goes to a 4. And the ones are gone on the bottom. That's cool, because that one actually is not going to have a fraction anymore. 3 times 4 is 12. Voila. I love it. Oh, let me start filling this out. 9x minus 1 is less than 12x. Are we good? Everybody knows where that 12x came from. Cool. See bobbleheads. That's good. That's cool. Next one is 3/4 times a negative 2. Or just 2 for now. We know it's going to be a common negative, so we're just going to do this. Times 2. We're just going to stick a little subtraction problem. Subtraction out in front. So let's go with it here. This is going to become a 2. That becomes a 1. And see, it looks on top. 3 times 1 is 3. 2 times 1 is 2. Oh, okay. So we have, oh, sorry. We have a negative 3/2 on our hands there. Are we good there? Well, it's at least a little bit better, because now we don't have to multiply by 4. We multiply now only by 2. So by doing that little process there, fractions or a distributive property has been done. Perfect. Let's multiply by a positive 2 everywhere. Oh, that's cool. I got different pin colors I can use. So how about this? 2 gets multiplied over here. And 2 gets multiplied over here. And again, it's another distribution process right there. But this one hopefully will go faster. And you guys tell me if I'm going too fast, okay? So 2 times 9, 18. With an x next to it, 2 times a negative 1 is a minus 2. Perfect. 2 times 12x is 24x. And then 2 times this. Tell me if you guys agree here, the 2's are just going to cancel, right? Because that's the whole point of multiplying by 2 in the first place. 2's are gone. And we got ourselves a minus 3. And all yours. Can you finish it off from here? I'm going to walk around just to make sure we're okay with it here. So give you guys 30 seconds, 40 seconds, 50 seconds. Just want to see how you guys are doing with that. Let's see. I see most people are subtracting 24x from both sides. That's cool.
So the way you want to calculate
it does not matter. So I prefer getting all my x's together on the left-hand side because then I know how I'm gonna read it that same way. All the numbers greater than that's right. You got to switch it at the end. Cool.
Oh, sorry.
Yeah, you switch it around because the x has to be on the left side. Okay, I got 3 different answers here happening. I got a 1/6, a 1/3, and a 5/6. So we'll see what happens out of this. Okay, I got 3 different answers, challenging. I got a 1/6, 5/6, and a 1/3. Let's see what happens here. All right. The way I would do it here, I would subtract 24x from both sides here. And you guys could have done it a little bit different, that's fine. That's a goner. 18 minus 24 is a negative 6x. Minus 2 comes down. Negative 3 comes down. And I'm going to add 2 to both sides. Negative 6x is less than negative 1. Everybody agree there? And divide through by negative 6. Oh yes, I know what happens here. This guy happens, right? This guy has to switch. And I'm left with a x is greater than 1/6. Boom, quick show of hands. How many got that one right before I gave the final answer?
Wait, I got that, but I still don't understand the squishy thing.
The switchy thing, sure.
Yeah.
The switchy thing is whenever you multiply through or divide through by a negative number, you switch the inequality. That was that little thing that we talked about. Yeah, in pre-algebra. If you were to multiply or divide, let's do that here because we do multiplication when we explain it. So if you were to multiply through by a negative 5 on both sides, the switchy thing has to happen because that's what happens with numbers in general. What we don't ever mention in when we teach this in math is the fact that multiplication and division, it's the same rules apply. So if you're at, let me think, negative 25 is less than 15. Everybody agree there? And I would divide both of these guys by negative 5. I divide this guy by negative 5. I divide this guy by negative 5. That becomes a positive 5 here. That becomes a negative 3. Notice the negative switched on me. And I have to switch the inequality. That's my little fun symbol for switching inequalities. Cool. All right, let's jam. Let's jam. Next one. Oh. Yes, I can do that. Okay, so.
Oh, that was annoying.
Okay, since Isabel does not like decimals, so let's see if we can get rid of them. So just like fractions, and you guys remember in middle school here, the whole concept of should have grasped middle school is the fact that percentages, decimals, and fractions are pretty much the same thing, right? We can convert between the two, right? Decimals, a 0.5 is the same thing as 50%, 50% same thing as 1/2, right? And part of 7th grade was to be able to convert between all those 3 pieces easily. All right, in terms of solving equations in algebra, we generally like to just get rid of them here. So all yours, anybody suggestions how to get rid of them?
Multiply everything by 10.
Multiply everything by 10 is perfect. So since we need to move the decimal place, oh, not that one, I like this one. Since we move the decimal place one time here, and one time here, I just need to move it once, and I'm going to get rid of my decimals. Moving a decimal place one time is multiplying by 10. If there was one number here, we had to move it twice, we'd have to multiply by hundreds. In this case, it's 10. So I'm going to go with it here. 10 times 15.6 plus a 3.1x multiply 10 over here on this side. Sweet. Oh, okay, gotcha. That's how that happens. All right, I'm just messing with something here. I should keep it like right here. Yeah, that works. All right, and you don't even need to calculate anything here. What we're going to do is just move the decimal place once here, move it once here, and once right there. All right, and all yours to finish up, if you haven't done so already. Thank you so much. All right, should be a minus. I wrote it as a plus here. There's the minus there, minus there. Makes a lot more sense here. Okay, I think some people are done already here, so let me just go for it here. I think I'm going to subtract 156. My x is already on the left-hand side, already set up for it. And anybody give me negative 52 minus 156? 208? Negative, perfect, yeah. Both negatives, add them up, put a common sign of negative there. Sweet. Next is divide through by negative 13, divide through by negative 13, and voila. Do we switch inequality, yes or no?
Yes.
Absolutely, we're switching inequality here. See, negative 13, does 13 go into 208? It does? Okay. How many times? 60. Oh, cool. Okay, you guys already know it. How did you guys figure that out? By accident, okay.
On purpose? How did I figure that out on accident?
Last time you added 50 to something, I got the right answer. Yeah, I know. He's really good at getting the answer of each one.
All right, how do we do it here? One way to do it is just to go and start simplifying 208 as much as we can, or try it on the calculator. But this would be what, half? If I take half of 208 would be 104. Take half of that would be 52. Take half of that. Since it's an even number, I'm just taking halves. 26, and voila, there's my little 13 right there. So 208 is really made up of 2 times 2 times 2 times 2 times 13. And if we divide out the 13, there's my little 16 that's left. We good? Perfect. Da, 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 da. Done. Oh, you know what we forgot to do? We forgot to graph these guys here. So 36, can you graph it? Something about parenthesis or bracket first. Parenthesis, awesome. And it's opening up to the left or to the right? To the right, yeah. Parenthesis opening up to the right. And then we shade off to the right. And we make the arrow a lot bigger, bigger, bigger. Cool, are we good there? All right, can you guys go back to 34 real quick here and graph 34? All right, 34. I have it underneath here. Tell me if you guys agree here. This is 1/6 is going to be between 0 and 1. Is that right? Because normally what we do is on a number line, we always put integers on a number line.
Oh.
So you start off, you don't have to start off with 0, because if it was like 124, 125 over 6, right? And at that point, you would figure out what's close to. What two integers is that between? So 1/6 is about right here. We're going to go off to the right. So 1/6 of the way to 1, about right there. Okay, and I'm going to shade it. I'm going to make the arrow bigger. And let me just do this real quick here. Let me walk around just real quickly here. For 34, 36, I want to see your graph of 34 and 36. Let's check out something here. Bigger. Okay. Just checking for something there. Cool, good, good. Okay, I'll do it on the number line. That's reminders. Yeah, okay, cool. Yeah, just want to, because sometimes when they start drawing it above the number line, it's not good. It should be right on the number line itself. Perfect. Okay. Short notation. Let's go with this guy here. This only works for bounded graphs. And so what we're saying for 37, let me make it bigger first of all.
Oh, so it's just in between.
Yep, it's in between. So you have a equation that's in between 1 and 9. So
Wait,
first thing.
Do we, when we do stuff like this, it applies, do we just treat those both like equal signs? If you multiply 3 by something, you multiply all 3 pieces?
Perfect. Owen is exactly right. So technically we have 3 different sides here, right? We have the left side, we have the middle side, and we have the right side. Notice also that it's couched between. So notice on this side, it has to be a 1, has to be a number that's lower. On the other side has to be a number that's bigger. So you're saying this little equation of 2x plus 3 is couched between a low number of 1 and a high number of 9. Good? Always has to be that way. It's always going to be less than or equal to symbols. It would not make sense if it's greater than symbols here. Okay, how do we do this? It is only for bounded graphs, which means starting point, ending point. This one is usually worked in science when you have, let's say you're working on a temperature and something, right? It has to be, temperature has to be between 50 degrees and 54 degrees. That's kind of like the little piece right there. Or this, you have a range of something and usually do that. It's kind of cool. Okay, oh, that's right. I can press this little button. It takes me back to normal. Okay, so let's begin. So if you guys notice, there's 3 different sides here now. So I'm going to solve for x, but I'm going to solve for that little middle section right there. So I'm going to, first things first, I'm going to subtract 3 here. If I subtract 3 here, I have to subtract 3 here and 3 there. So we're working on all 3 sides at the same time. So 1 minus 3 is a negative 2. That cancels because that's exactly what I wanted to do. And then 9 minus 6 minus 3, that's 6. Perfect. And last step, divide by 2. And I'm good. Exactly where I want to be here. So divide by 2, divide by 2, divide by 2. Have to divide all 3 pieces. And I got myself a negative 1, x right here, and a 3. Okay, how do we graph these? We've graphed them before already. We start off at negative 1, we go up to 3, and the question is it's bounded, so it's going to be in the middle. And parentheses or brackets? Parentheses. So parentheses starts at negative 1, ends at 3, and everything in between. Boom. Okay, that is short notation right there. It only works for the and stuff. So the number that I'm looking for, the number that I want is between negative 1 and 3, or negative 1 is less than the number that I want, and the number that I want is less than 3. Okay. Yeah, could be negative half, could be negative 0.99999, right? Could be 0. 2.9? 2.99999. Okay, that's the easy one. Let's go with the little bit more complicated one. What happens if we involve a lot more things? Nah, why stick with the easy ones? We can move to more difficult ones. So notice this one again, setup is the same. So when we see these, we got to think about this here. Is the number on the left side smaller than the number on the right side?
Yeah.
Yeah, negative 8 is smaller than 13. That's good. Next is, do I have less than or equal to in there?
Wait, so does this mean we can't multiply through by a negative number because then you have 8 being smaller than negative 15?
That's why it's a difficult one. It should, but when it should work exactly the same. It should kind of, by the time you finish it off, like, oh, that makes sense.
Yeah.
All right, we good? Writing it down. Let me try it here. So first things first, you guys talk to me. What should we do? Add 5 to both sides. The only little problem I have.
Yeah, I already distributed it.
Okay, distribute the negative. That's cool. Okay, like we did last time here. She's ahead of herself here. So distributing the negative. Negative 3x. Distributing the negative over here. Minus 5. Good. Step 1 is done. And Maddie said step 2 is add 5 to all sides here. So negative 3 on this side, negative 3x on this side, and a 18 over here. All right, next step. I think we got to divide by negative 3, right? Because it's the middle that we need to solve for now. Negative 3 here, negative 3 there, negative 3 there. And what do we do when we multiply or divide through by negative? We have to switch that inequality, flip the inequality there and there. So how about a 1 over here? That gets flipped. That gets flipped, and we got ourselves a negative 6. Oof. Not the way we like to see it at all. So here's what we're gonna do. We're gonna flip it just like we do. Just like we do a pancake. We good? Anybody flip the pancake on a pan? Right? You go like this, you flip it, it's gonna go, everything's gonna go the other way now, right?
So actually group 1 could be correct again.
Oh my God.
For this one,
Dave,
yes.
That's not the point of the sequence. Always right.
For simple ones, yes.
It's like 1.
So can we flip this around completely? I'll put the negative 6 over here. I'm going to switch the inequality. Notice I'm switching this inequality. X is in the middle. This is switched, and that's a 1. Are we good there?
Do you want us to switch it around so it's all going this way?
Yep. It has to be, because that's the way it's written. That's the inequality solution to this problem. Okay. So the question is this: do we still have a small number over here and a large number over here? Yes, that means it was not screwed up. We're good. And can you guys graph it for me?
Yes, sir.
So do a bracket, do a parenthesis wherever it's needed.
Yes, I am.
All right, let's go with the negative 6 here. A positive 1 there. And how about a parenthesis at negative 6? How about a bracket at 1? And how about a shade, and it's bounded again. There it is. Ignore it.
Oh,
Okay. Are we good there? Almost done with inequalities here. All right. How about, let's see, we got the negative inside there. Now we got to deal with the fraction inside there.
that looks fun.
Zoom in. Thank you so much for the reminder. All right, let's see. Did I send out a study guide to you guys for the test?
Yes.
I did send it out. Good, good. Okay. Focus. Oh, yeah, that's right. We covered it last time, right? The focus is factoring or multiplying and factoring, focus solving equations, and this inequality stuff right here. That's the 3 things they should focus on for the exam. Okay. Let's deal with the fraction. You guys tell me, because math makes sense. It totally does. So the question is, what do you think we should do here? Multiply by 2. Perfect. Camille is perfectly correct. Then multiply by 2 here. Multiply by 2 here, this big old thing over here. And multiply by 2 over here. And the rest should look a lot easy now. That's going to be a 0, 2's are gone because that's the whole point of multiplying. That's what we did it for in the first place. And I got a 10 over here. And I'm going to go with subtract 3 everywhere. And I think you should be almost done. So negative 3, x, and how about a 7? Cool. Can you guys graph it? If not done already. Done already? That was that simple? Oh, awesome. Perfect. Negative 3, 7. Bracket negative 3, parenthesis at 7, and we're good to go. So bracket means we're including the negative 3 as our answer. Parenthesis means we don't include 7. 7 is not part of an answer. 6.9 is, 6.999999999 is, but not 7. All right, someone likes the motorcycle. Okay. And of course I got to put decimals in. Which other way can I torture you besides putting decimals in? Again? Yes, thank you. Right there, 44. All yours, Abe. We got fractions and decimals at the same time.
You got this. No, this looks so hard.
All right, and talk to me here first. What do you think you're going to do first? Multiply by 2, perfect. Joe and I totally agree. Multiply by 2. The only problem there, that after you multiply by 2, you still have a decimal. Look at that. They're just messing with you. That's all it is. Multiply by 2. No, not by 2. By what? By 10. Yep. So, yep, even big numbers. I think we can handle it. So you guys said multiply by 2. That's perfect. 2 times 4.5. (1.5x plus 6). That all gets multiplied by 2 as well, right? That's the whole point. That's 9. That's 1.5x plus 6. That's 21, I believe. Let's see. Multiply by 10, I heard, right? Multiply by 10 because of the 1.5 still being there. So multiply by 10. Multiply by 10. Multiply by 10, 90. 15x plus 60. And how about 210? Are we good there? All right, subtracting off, and hopefully you guys are doing ahead of me here, because this should be easy by now. This is like, oh yeah, Mr. Hunji, if I just do this.
But I have a question.
1 second, let me just finish off real quickly. This is 150. Divide through by 15. Divide through by 15. Divide through by 15. I'm going to write it up here. So 30 divided by 15 is 2. That's x, and that's 10. Oh, my signs are facing the other way, right?
Yeah.
So do we have to flip it around? So let's flip it around. 10 goes over here. Less than x, less than 2, right? We flip it like a pancake, right? Boom, goes the other way.
10 less than 2.
Math. Almost. It's a long story, but it works.
So we have, oh, Isabel saying we got a little problem, don't we?
Yeah.
We're trying to find a number that it's bigger than 10. That's what this means. A number that's bigger than 10. At the same time, that same number is less than 2. Is that?
But then you have a negative back.
Yeah, you have a negative back.
And then you have to.
No, it's one of those graphs where you have like things going up in both directions. Right?
Ah, cool.
Wait, actually? Let's do it. Let's do it.
Okay.
None of them.
Owen, real quick here. Owen, not true.
Oh, it's not.
So For this one, no solution. This is not possible. It doesn't make sense. You can't have something that's bigger than 10 at the same time less than 2. That does not work. Now, Owen, I know what you're talking about though. If you had something like this, if you had x is less than 2 or x is bigger than 10, that's what you're doing. But these guys are not ors, they're ands. So both have to be true at the same time. So answer is no solution. Hold on. Class, real quick here, 44. If I were to go back and look at the problem before I even started doing this problem, could I know that there was no solution? Yeah.
So we could just written NA from the beginning?
I know, isn't that a bummer? You guys just start chopping up at the problem here.
Oh.
Right? It's not possible for that even to happen.
Oh.
Well, because we already said that 4.5 is less than 10.5.
Yeah, so you did have to switch it around, right? Because the numbers are kind of switched. So if you switched it around to this, and you had 1.5x plus 6 over 2 less than 4.5, you would have said, no, this is not going to work out at all. So at this point, you would have said NA, no solution, or NS.
Check for that quality problem.
Hey, all right, good, good. Isabel has a great idea. Before you start doing the problem itself and spending a whole page on it, Abe, check to see if you can even do it in the first place. Okay, I think we are ready. We are ready for inequalities. So those were, it's called bounded sets and short notation. We good? Next is flip to inequalities. Or inequalities with absolute values, and this is where we're going to end with. I think we end here. Yeah, and then example problem. Oh yeah, no, just the exercise stuff. Okay, so here it is. Let's talk about this here, because this will have to make sense as we do these problems here. Let's set it up first. Let's figure it out, and then we'll get the rules from it, okay? So first things first, we did this already before when we were picking up values. I want to make a little graph. This is a setup problem here. Let's kind of think about, you know what, real quick here? Sorry, guys, real quick here. I'm going to change up the problem for you guys, okay? Let's put in our notes, let's put in an equal sign over here too. Put an equal sign here. And then over here on the side, you're going to put 46. You're going to put a little star next to it. You're going to put this, and we're going to switch the inequality around the other way. So I want to do these two problems with you guys. Let's see if this will make sense as we do them. If numbers work out, that means the algebra has to work out. That's it. Algebra is based upon pre-algebra. So when you work with numbers, when we take it to algebra, we put an X in there, it still needs to work out the same. So if I were to make a number line, let's talk about this here. If I make a number line of all the numbers that work for this. So I'm saying this, for 46, the first one, I'm saying this. Whatever number I put in, if I take the absolute value of it, that number has to be greater than or equal to 4. We good? So let's try some numbers. -6, you guys tell me yes or no, works or not works?
Yeah.
Okay, so I'm going to set up this little number line. -6, -5, -4, -3, -2. I'm going to skip to 0. I'll put 2, 3, 4, 5, 6. I'm going to squeeze in those guys here. Okay, ready? -6 works or does not work? Yes. -5 works or does not work?
Yes.
Let's go. Thumbs up for working or not working. We good? -5 works or not works? -4 works or not works?
Yeah.
Yeah, it's going to be equal to that. It still works. Okay, -3. No. Okay, -2. 0, 1, 2, 3, 4. Okay, starts working again at 4, 5, 6. Yeah, even though I messed up right here. 5, 6. There you go.
Oh, this is the one where it goes both directions.
All right, so Owen, right, this is the one that goes different directions. There it is. So we say this, it's going to be a bracket at -4 going off to the left. It's going to be a bracket at +4 goes off to the right. And so now how do we say this? We say this, we say that x, the number that I want, is less than -4, or the number that I want is greater than +4, or greater than or equal to, sorry. Are we good? So that's the way it splits. It splits with numbers like this. It goes to here. Guess what? Actually, I can split this off already. This is, let me get the rule here. Okay, so for absolute value, and if the number is greater than some kind of number, we say this is true. I wonder if it works if I just switch the number around. Let's just do this one again real quick here. So true or false, real quick here, from -6 to -5, to -4, -3, -2, go all the way down to 0, 1, 2, 3, 4, 5, 6. Okay. I switched my inequality around.
Like, yes, you want a graph because then.
Oh yeah, we're gonna get there in just a second here. So real quick here, I plug in the value. You guys tell me up or down. Does -6 work? And -5.
No.
-4.
Yeah.
-4 works. Okay. I'm gonna fill a dot there. -3.
Yeah.
-2.
Yeah.
-1.
Yeah.
0. 1. 2. 3. 4. 5. 6. Okay, so in this case, what we have is we have this. We have something that's in between, right? -4 to, oh, that is so cool. We're getting somewhere, guys. We're getting somewhere. We're getting somewhere pretty cool. Okay, I got this here. How do I write this as an answer? And then we just did it just now. Isn't this bounded? Is that right? Isn't this bounded from -4 to +4? So if I were to write the answer here, I would write it like this. I'd say -4 is less than or equal to x, which is less than or equal to 4. Everybody agreed? Because we're trying to set up some rules to deal with absolute values. Okay, so I got my 2 rules. There it is.
Wait, for the first one, will we have to write both answers?
Yes, for the first one, you have to write both answers because you're saying, hey, look, it goes one direction this way, or it goes the other direction this way.
Why can't we just write it with the absolute value? Isn't that like plus or minus kind of?
Because we're trying to develop some rules to break it away from absolute values. So notice the problem itself has absolute values inside it. The answer does not have any absolute values on it. Okay, why did we do this in the first place? Is to develop rules for absolute value. So if I jump to this one, ching, here's my little rule. Ready? We're going to go backwards here. So if I have a less than symbol or a less than or equal to symbol, if this, and probably write this one down, if you guys can. Write number 1 as a rule like this right here, this piece right here. That was the rule that we're just doing. So if the absolute value is less than an A value, what's going to happen is it turns into this right here, which is what we did with 4. So less than or equal to, it doesn't matter, it's going to work the same way. We good? So if the absolute value is less than a positive number, it's bounded. It's bounded within a little set, and we can write it using short notation. If the absolute value of something is greater than a certain number, then it's not bounded. It's going off in 2 separate directions. And if that's the case, we've got to put an or in there. And notice what it does. Look at this. Let's see if we can kind of go back between our 2 problems here. Notice it says x is, we switch the inequality here, and we take the negative of a. We're good. Let's go back to see if it works for our numbers. We're good. We've got to just kind of go back and forth. So everybody agreed with number 1. Number 1 is kind of like the second one that we did. This one goes to here. What we do is we take the opposite. Whoa. Sorry. We take the opposite of this guy. We keep that sign exactly the same. We put down the x without the absolute value. Same symbol anyways, but now the positive of that answer. Are we good? Because it has to be bounded on this side of the negative of it, and then the positive, and we're stuck in the middle. Good. The other one is, notice what we do here. X is here. We switch the inequality. We put a negative in there. Or we write down exactly the same thing without the absolute value. So what we've done is we've undone the absolute value by doing this process. Okay, good, Dave? We're good there? Let's jam. So let's start working with absolute values or inequalities with absolute values. So the only thing you have to remember, memorize it, whatever you need to do. So if you have a less than symbol or a less than or equal to, you're going to use this rule. If you have greater than or greater than symbol, you're going to use this rule. One more little disclaimer. You guys ready? This little guy right here. A has to be greater than or equal to 0. It will not work if A is negative. If A is negative, it just screws up everything. Okay, we're good? So here it is. We're going to solve absolute value problems. And after solving it, we're going to graph them. That's what we need to do. Solve and graph. Let's do some easy ones here before we have to get out of here. X, absolute value of X is less than 6. Oh, these should be easy here. Okay, we go directly to answer. Is this bounded or unbounded? That's what I want to say. Bounded or unbounded? Or rule 1 or rule 2? I like bounded or unbounded. I like them. It's bounded, right? It's bounded. You absolute value, those numbers can't be any more greater than 6, right? So you go back and kind of just think about 2 different ways here. Go back to the example problems if you need to. It's this one right here. Or go by the rules. It's this one here. It's bounded. We are going to write it like this. This is sweet. I go directly to answer. Here it is. I'm going to go opposite of 6, same symbol, X without the absolute value, less than the positive 6. Done. We're good. I've undone absolute value. And I can graph it now. Negative 6 to 6. Bracket or parenthesis? Parenthesis. Whoa, poll question. No, not today. We done. There it is. I've solved it and I've graphed it. Okay, 46. Bounded or unbounded? Unbounded. So those numbers have to be bigger than 4. The absolute value of those numbers have to be bigger than 4. So you're going 2 different directions. That's cool. So the way I write it, I think I write it like this. I go, X is going to be, switch the sign around, take the negative of it. X is less than negative 4, or I write the exact same stuff, but without the absolute value. Good there. I just want to make sure that this is one of those, if it makes sense in your head, the light bulb is on and we're good to go. Cool. Okay, can you guys graph this one now? So negative 4 in this end does something, positive 4 in this end does something. All right, Dylan, are we good there with that? Does that make sense? Charlie, we good? So unbounded or unbounded, we just need to figure which one. Once we do that, then we can go to the equations. So I'm going to go parenthesis here to the left, make the arrow bigger. Parenthesis here to the right, and make the arrow bigger. Now, is this the easy one? Or ones? Yes, these are the easy ones. Now let's get into some more fun stuff here. 5 minutes to go. Let's see how much we can get done. So let's tackle some strange ones first. We good? And then we'll do the other stuff. Absolute value of X minus 7 is less than negative 5. Let's handle the negative answers first here. Remember, A has to be positive for those 2 rules to work. A is negative, the rules don't work anymore. The rules don't apply. So, talk to me here. This is a thinking problem. These absolute value stuff, it's always going to be positive, is that right? What numbers, if I stick in here, I subtract 7, I take the absolute value of it, and that number is going to be less than 5.
Less than 5 or less than negative 5?
Sorry, less than negative 5. Thank you. So let's plug in like a 0. 0 into there, 0 minus 7? That works, right? Yeah, because it's going to be 7, right? Plugging in a 3 into there, that's going to be a -4. Absolute value of -4 is a 4. 4 is less than, hold on, no. Is 4 less than -5? No. Is 0 less than -5? Is 7 less than -5? No. Okay, so real quick here, let's develop some rules here, or let's put this here. Everybody agreed with no solution here?
Yeah, there's nothing, because everything's gonna be positive, and you can have a positive that's smaller than negative.
Perfect. Okay, so then let's develop another rule here, which is really not normally written in textbooks here, but like this. Tell me if you guys agree or not. There's my little rule, right? If that's the case, if absolute of x is less than -a, there's no solution in my hands. Check something real quickly here. Okay. Let's do 50. Let's do 50 star. 50 with a star next to it. I just changed one little simple thing, and let's see what happens here. Oops, please go say again, say it louder.
It's gonna be greater no matter what.
It's gonna be greater no matter what. Everybody agree? Yeah, I stick in the negatives, stick in a 0, it's gonna be a 7, the 7 is greater than, yep. So in this case, it's gonna be all real numbers. So the rule here is that if absolute value of that is greater than -a, the answer is all real numbers. Okay, we handled the weird stuff. Yeah, we have just enough time to do one of the absolute value problems here. Okay, I think we're ready to start. So always check to make sure that number is positive. If positive, the rules apply. If that constant is negative, it's going to be one of these guys. It's going to be no solution, they're all real numbers. All right, on your mark and set, and let's go. One problem. Of course I'm putting fractions in it. Of course I'm going to torture you a little bit. So absolute value of 1 minus 2x over 3 is going to be less than 1. Ooh, hold on. Bounded or unbounded? It's bounded. Okay, perfect. All right, because of sake of time here, I want to finish off this problem here just so you guys can start it at home. Dunk. So you guys are able to do absolute value problems now. Okay, let's do it. It is bounded, correct? Bounded, which means it's bounded between -1 and 1. So let's go with it here. So -1 less than 1 minus 2x over 3, which is less than +1. Everybody agreed with that? That's what we've been working on all this time. It's bounded between these guys. What should we do? Because I think we just did these things. Multiply by 3. Get rid of our, hey, we've been doing this, right? Just today.
Multiply by -3 if you wanted to get rid of it.
You could, yeah. Initially, It just kind of looks kind of weird at first when you do them, but yeah. So let's go real quick here. We got a minute and a half left here. Multiply by 3 everywhere. Go. And let's see if I can finish up in time. Okay, I'm going to go kind of fast here, guys, to finish up here. That's -3. That's going to be 3 minus 2x. That's going to be +3. I'm going to jam here. Subtract 3 from both sides here. That's a -6 less than -2x, which is less than 0. Divide through by -2. That should be a 3. We've got to switch the inequality around. Got to switch that inequality around. And then we've got to switch it back. Is that right? So 0 less than x less than 3. And I think we can graph it now. So our answers are stuck between 0 and 3. Are we good? I'll let you guys copy. Those that need to copy it down. Those that need to get going, go for it.
Thank you.
Uh-huh.